Okay. So let me show you. Okay, so I think you were going to try this one, right? The alternate interior? Okay, did you try it?
I was trying to, but the letters, like, I feel like it's more easier with numbers instead of letters. I don't know.
Right, right, true. Okay, let's just try this one. This one is very, very similar to what you would do on that alternate interior angles one. So let me just show you what this one kind of looks like. So here we're trying to prove that FGC, so this angle, actually it'll go like this. If we just hover over it, it actually shows it on the picture, which is nice. So we're trying to prove that those are congruent, okay? And it's already telling us that these two lines are parallel. Okay, so if you remember from the worksheets and stuff that we did, these are, see how they're like in the outside, I guess, they're out here and out here, they're not interior, right? So these are actually alternate exterior angles. So there's actually a theorem that says if the lines are parallel, then the alternate exterior angles have to be congruent. So we're just going to go like this. We're going to click on an unjustified claim. And then there's all these possible things that we could justify it with. So do you see right here how that looks a lot like this picture when we hover over this?
Yeah.
Yeah. So this is a theorem. It's just a picture to represent the theorem. But it says that if two parallel lines are cut by a transversal, hold on, let me let the dog out so she'll quit barking. She's super annoying. Okay, anyway, so if we click on this, then all we have to do is fill in these lines, but a shortcut to filling those in is I can just click on this gift up here in the corner.
Yeah.
And then I just need to name the transversal, which is the line that cuts the angles. And there's all these lines because we could be talking about any of those segments. So we're just going to pick the whole thing. So the whole thing is EF. And then it will automatically prove. Do you see how down here is now matching what's up here, what I'm trying to prove?
Yeah.
So if I click submit, I'm done.
Oh.
Yeah, it's kind of the one, I feel like the ones that are only one or two steps are actually a little bit harder than the other ones because you just don't think it could actually be that simple, but it is. So let's look at another one. Do you want to try another one? Do you want to try a triangles one? Do you want to try a quadrilaterals one?
Quadrilateral one.
Okay, let's look at the quadrilateral one. Oh, I already did all of these. Okay, hold on. Let me see if I can remember. I made myself another login. Let me see if I can.
Sorry, I'm not sure about that.
Get on it.
Alexa, what is the weather today?
Hunter, I'm on a video, bud.
Right now in Payson, it's 34 degrees.
My children have no idea what's happening right
Today's
now.
forecast has partly sunny weather, the high of 54 degrees and a low of 30 degrees.
Okay, hold on just a second. Okay. Okay, now there's some that I haven't done. Okay. So pick one. Doesn't matter to me.
Angles.
Angles of a parallelogram, this one?
Yeah.
Okay, so the other thing that will help you too is that this is a level 1 proof, so this is going to be another one that's pretty easy like the one we just did. And then on these level 2s, you're going to have some extra steps in there. Okay, so we'll do a level 1, but then maybe we'll do a level 2. because that will be good for us. Okay. All right. So again, we hover over that and it shows us that we're trying to prove, and those would be considered opposite angles, right? From the quadrilateral stuff that you did. Yeah.
Yeah.
Okay. So we already know that if this is a parallelogram, that opposite angles are going to be congruent. That's one of the things that we learned with those other two assignments. So I'm going to show you something magical. Oh, please let go. I don't want to do this. Okay. So if I click on something that's already justified, this little gift, it's a present that they gave us. Okay. If I click on that, then there's all this information. This is all information that I now know has to be true about this shape.
Yeah.
All of these things in here have to be true because they told us it was a parallelogram. So do any of these things look like they would help us prove that?
Yeah.
Like which number? Which thing? The first, second, third, fourth, fifth?
The third one.
Yeah, do you see that?
Yeah.
It says in a parallelogram, opposite angles are congruent. So we click on it and it says, oh, okay, so ABCD is a parallelogram. And we just want to prove, and we can actually just click on it so we don't have to worry about what letters it is. We click on that angle and that angle. And then we push submit, and guess what it's gonna do? Well done, good job.
Yeah.
Should we try a harder one?
Yeah.
Okay. I think the ones with algebra in them are a little bit tricky. So we could try one of those if you want.
Yeah.
Yeah. So one of these bottom three.
The second one.
This one?
Yeah.
Okay, here we go. All right, so this one wants us to prove that angle bay is 24 degrees. Okay?
Yeah.
So can you see when you look at this picture over here, does it make sense to you that that would have to be 24 degrees?
Is it because they're vertical angles?
Nope. But do you see this shape right here? Let's see
Yeah.
if it'll let me click on it. Oh, it won't. Hold on. But just look at, do you see this shape? What shape is this right here?
A triangle.
Uh-huh. And how big do you think, if you had to guess, how big do you think that angle is right there at E?
Around 90 degrees.
Yep. So then, does it make sense that this little guy up here would have to be 24?
Yeah.
If that one is 66.
Mhm.
Okay. So the question is, how are we going to prove it? Because we don't just get to say, oh, it looks about right, and oh, that's probably about 90 degrees. We don't get to do that. But if we click over here, it tells us that this shape is a rhombus. And remember, I told you, if you click on the things that are already justified, it's going to tell you some things that are true about a rhombus.
Mhm.
Do you see anything in that set of pictures that will help us?
It's either the second one or the third, I feel like.
Yeah, the second one or the third one. So the third one is talking about how those angles at the end are going to get cut in half. And that would help us if they told us the measurement of like DAB. If they told us that big angle, then that one would help us. But I think from the conversation we had earlier, it might help us to know for sure that this guy is 90.
Yeah.
So we're going to use this second one.
Mhm.
So anytime your shape is a rhombus, you automatically get 90-degree angles on all 4 of these angles. When you like cut it like a kite, you get 90-degree angles in there. So we're gonna use this. And it's gonna say, okay, so ABCD is a rhombus, which means that what lines are gonna be perpendicular? So this line, AC, is gonna be perpendicular to this line, which is BD. Okay, so all it has right now is that those are perpendicular, but we actually need a number. We need the number 90 degrees inside of that angle so that we can make the computer do the math to figure out that these 3 angles added together has to be 180, and this one was 90, so this one has to be 24. Okay, so I'm going to click on their perpendicular. And I'm going to, do you see how there's 3 options here? So perpendicular lines meet at a right angle. Parts of perpendicular line segments are perpendicular. Diagonals, and it's a rhombus. Or divides it into 2, we don't care about that. But this will help us, because if we can say for sure that BEA right here, if we can say for sure that that angle is a right angle, then we'll be able to have the computer put a 90-degree measurement right there. Okay, and it's kind of annoying because it's like 3 steps when we know automatically, like in our heads, we know, okay, if they're perpendicular, then it's 90. In the computer with a proof, you have to go all the way through it. So now we have over here in Justified, we have their perpendicular. Then we say they're a right angle. We got to do one more thing. So annoying. If you know it's a right angle, you have to do this. So if we know that AEB is a right angle, then we know that the measure of AEB is 90 degrees. Yeah?
Yeah.
Okay. So now what we're going to do is we're going to talk about all 3 of these angles together. What do we know is true about all 3 of those angles?
They all add up to 180.
Good, because they're in a triangle, right?
Yeah.
And that doesn't seem to be showing up like in our justified claims or anything like that. So I'm going to push add a new claim. Okay, and my claim is about angles, so I'm going to click on angle. And then do you see anything in there where there's 3 angles that add up to 180?
Very last one, let me see.
Yeah, do you see that?
Yeah.
So sum of 3 angles is 180 degrees. And then it's just going to force us to fill in the blank. Okay, so we're going to say the measure of angle, that one. And we can just click on them, which is nice. Plus the measure of angle, that one. Plus the measure of angle, that one. Those all have to equal 180 degrees. And then when I click confirm, it's going to ask me for the reason why. Why would that be true?
Because
And you have 2 options. Yeah, do you see it?
Yeah, they're supplementary angles.
Good. So the 3 angles, so we have this option. If they were all stuck together on a straight line, they would add up to 180. Or we have this option. They're the 3 angles inside of a triangle, so they have to equal 180.
Yeah. That first one.
Yeah. And then it just wants to know what's the name of the triangle that we're using. And we can actually just click on it. It's triangle ABE. And then submit. So we're close. I know this one seems like it's taking forever, but we're close. So we know that all 3 of these angles add up to 180. And we already know the other 2 measurements, right? Over here in our justified claims. We just need to make it show that this one has to be 24. So I'm going to go like this. I'm going to use the algebra manipulator by clicking on the calculator. Okay. And then I want to replace these with numbers. So do you see DBA is 66 up here? Do you see this?
Yeah.
So if I grab this, I can pull it on top of DBA. And when I let go, it'll replace DBA with 66.
Okay.
Okay. Which other one do I want to do that for?
Angle E.
Yep. So I'm going to do it for AEB is 90. Bring it over here. Drop it. Okay. And then it looks kind of annoying. Like it seems like we need to simplify that a little bit. And it doesn't just let us like type in what it should say, but it will simplify it if we ask it to. And the way we ask it to is we hover over these and we click on it and it will simplify that for us. Okay, and then what would you do if you were doing this by hand on paper? What would you do right now to get to this final answer right here?
I would use substitution.
Okay, what would you substitute?
Angle E with angle B.
Okay, I see what you're saying. So actually all we have left that we have to do, this is a little, I didn't realize I had made this mistake, but do you see how right here I'm trying to prove angle BAE?
Mm-hmm.
So BAE, do you get that that's the exact same thing as angle BAC?
Yeah.
Can you see that when you look at the picture? So right here, we're saying that the angle that we want to know, if I add 156 to it, I get 180. So what I want to do, what I'm thinking would be fast, is if I just subtract 156 from both sides. What will it say if I do that? Will it basically say what I'm trying to get?
Probably, yeah.
Okay, so what I'm going to do is I'm going to grab this 156, maybe. Oh, it won't let me. There we go. If I grab it and just pull it to the other side, do you see how the light gray underneath is automatically going to subtract it?
Yeah.
It's like I have to do it, but the computer is kind of reading my mind at the same time. And then do that thing I showed you where you hover over it and click on it, and that'll simplify it for me. And then I'm going to push submit. And I'm done. Because when I submit that, I've just said that that angle right here at the very bottom, I just said that that angle was equal to 24, which was what was in this unjustified claims at the top. That's what I was trying to figure out. So because I got to that point, I'm done. That one was a little longer, huh?
Yeah.
Okay, do you want to do another one?
Sure.
Okay, which one do you want to do now?
The angle of a rectangle.
This one?
No. Yeah, that one.
Okay. Okay. Sorry. All right, so when I hover over it, it wants me to prove that angle BAD is congruent to angle CBA. But what kind of angles are they?
Right angles.
Yeah, they're both right angles. And how do you know that they're both right angles for sure?
Because they have that little square on the bottom.
Yeah, they have that little square. And the reason they have that is because of this guy over here. What shape is that?
A rectangle.
And we know that rectangles are made up of, will you go get that from?
What?
Go get that from Missy. Oh. Sorry, my dog is being naughty, running around the house with my expo markers. Okay. Okay, so we know it's a rectangle, and in a rectangle, all the angles are 90 degrees. Well, if all the angles are 90 degrees, then aren't these two angles going to be the same?
Yeah.
That seems to make sense, right? Okay, so we're going to go like this again. They gave us information, so we're going to click on it. And do you see anything in those options that would help us prove that those angles are the same measure?
Yeah, the first one.
Good. So it says each angle in a rectangle is a right angle, but it's only going to let us do one at a time. So our first angle, we're going to say this guy is a right angle. And we're going to submit. And then we need to do it again, right?
Yeah.
We don't need to do all four, but we need to do the two that we're interested in. So I'm going to do the exact same thing again, but for this angle. Good?
Yeah.
Okay, and then if I know that these are both right angles, then they have to be congruent to each other. So let's look at this. Let's see if we click on here. Is there a picture that makes it look like that statement that I just said, that if they're both right angles, then they have to be the same?
The fourth one.
Let's see what it says. It says all right angles are congruent.
Yeah.
So it says right angle, and then it says prove that they're congruent. Dog, she's so naughty. Now she's eating somebody's deodorant. She is the worst dog on the face of the planet.
Hunter's Axe deodorant.
Sorry. Okay. All right.
She's a little nasty.
So we'll click on that. And then it kind of filled it in already for us because we already had the information over here. So it says if angle BAD is a right angle and angle CBA is a right angle, then BAD must be congruent to CBA. Look at this. That matches. So what's going to happen? Well done! You did it!
Yeah.
Are you getting the hang of it?
Yeah, I'm getting hang of it.
Okay. You want to try some on your own and then email me if you get stuck?
Yeah, that'd be good.
Okay, cool. Are you okay if I post this video so everybody can see it?
Sure.
Okay. You're the best. Okay, have a fun afternoon and then no math over spring break, okay?
Okay, thank you.
Okay. All right, bye.
Bye.